Hi friends, welcome back to new session. In the last session, we discussed about commutation, and I told you because of a poor commutation, delayed commutation, so we'll be having some sparking of the brushes. So to reduce the sparking of the brushes, in olden days we were using shifting of brushes along MNA. In nowadays we are using interpoles or compoles to reduce sparking the brushes or to improve commutation to reduce the cross magnetizing effect. Let us see. Let me discuss interpoles or compoles in this session. Okay. See guys, first of all, interpoles or compoles are used to reduce cross magnetizing effect to reduce sparking of the brushes. Okay. So before explaining interpoles or compoles, first of all, try to see in the last session I told you. So reactance voltage is the voltage which is opposing your commutation. Thereby your delayed commutation is coming. Because of delayed commutation, you are getting a sparking at the brushes. That means you have to compensate this reactance voltage. So therefore definitely I'm using interpoles or compoles to compensate this reactance voltage by inducing some more EMF opposite, in the direction opposite to this ER value. Okay. So here interpoles or I can say our compoles are small in size when compared with the main poles. When compared to the main poles, they are small. And my question, so tell me guys, where you have to place interpoles? Tell me first of all, where you are getting sparking at the brushes. Tell me brushes are shown along Q axis. Therefore, definitely you have to place interpoles or compoles along interpolar region, or I can say Q axis, or I can say brush axis. So they are located in the interpolar region between two poles. Very important, note here. Interpoles are small in size. They are located along, they are placed along Q axis, or I can say interpolar region. That's very important point here. Okay. And one more thing, interpoles, just like if you see in the previous sessions, I just discussed about composite winding. Compensating winding was connected in series with the armature, like that here also. Interpole winding is connected in series with the armature winding. So here see guys, interpolar winding is connected in series with the armature winding. This point is very important. So if you remember this point, it will be useful for solving one question. If you remember that point clearly, this GATE 1995 one mark question can be solved without wrong. Okay, what is that? Interpole winding is connected in series with the armature winding. Next, guys. And please tell me, if you remember while I was discussing about compensating winding, I told you compensating winding, yes, no doubt it will neutralize armature reaction. It provides uniform flux distribution along polar region, or I guess along a d-axis. It reduces flashover on a composite surface, that is okay. That means compensating winding provides uniform flux distribution along the d-axis only. Suppose if you want to provide uniform flux distribution along q-axis, no doubt I need to use interpoles here. So first, if you observe clearly, by using this interpoles or compoles, I can provide uniform flux distribution. Uniform flux distribution can be provided along a q-axis. So for that I need some flux, and I need to induce some EMF which will oppose your reactance voltage. For that I need some flux once again along the Q axis. So guys, try to understand. So I need more amount of flux. One for providing uniform flux distribution along Q axis, another for inducing some EMF which will oppose reactance voltage. So obviously requirement of flux due to interpoles is more. If you want more flux, definitely MMF of interpole should be more, no? Because everybody knows that flux is proportional to MMF. Flux equals to MMF by reluctance. Flux is because of MMF only. So definitely, MMF of interpole winding is more than MMF of armature winding. That only I had given here. MMF of interpole equals to 1.2 to 1.3 times MMF of armature, I can say. Why MMF of interpole is more means because requirement of flux is more. Why requirement of flux is more? Because I need two flux here. I wrote here. Interpoles provide uniform flux distribution along Q axis. Interpoles produce counter EMF in the coil. For producing that counter EMF, I need some flux once again. So this counter EMF will oppose your reactance voltage. Okay, so that's the reason to oppose your reactance voltage, I need to produce some counter EMF. For that I need some more flux. So for having these two functions, yes, for having about two functions, flux required due to interpole winding is more. That's why mmf of interpole should be equals to 1.2 to 1.3 times mmf of armature. In addition to this, you have to remember one more point here. What is that? So I told you requirement of flux is more along Q axis. So if you want more flux due to interpole winding, so guys, try to take care such that this interpole should not enter into saturation. So if I don't want interpoles enter into saturation very fastly, so air gap should be more here. That's why if you observe clearly this figure, air gap between interpole and armature is more than air gap between main poles and you can say armature. So guys, yes, interpoles designed with a large air gap with armature. This one. What is the reason? In order not to get saturated when the load current flows in the interpole winding. Okay, guys. So that means if you want more amount of flux, it should not enter into saturation. If it enters saturation very fastly, I won't get required amount of flux, whichever I need. So definitely air gap should be more, so to avoid interpoles enter into, you can say, saturation. Okay, and here some people may get out. Suppose if you provide a counter EMF which will oppose your reactance voltage, obviously this is the reactance voltage is the one which will oppose your computation. Because of the opposition only your delayed competition is coming, sparking the brushes you are getting. Suppose if you are opposing your reactance voltage, obviously sparking at the brushes can be reduced. So that only I had your conclusion here. Interpoles improve commutation by compensating your reactance voltage. Okay, so it reduces cross magnetic effect, it reduces sparking at the brushes by compensating reactance voltage, okay, which is responsible for delayed commutation or against sparking at the brushes. So what is the conclusion here? Interpoles reduce cross magnetic effect. This question they may ask. Okay, similarly interpoles improves commutation, they may ask this question also. Interpoles reduces sparking the brushes. Yes, they may ask this question also. So please, they may ask you in so many ways. Try to remember this note. And what about compensating winding, which we discussed in the previous videos? Compensating winding reduces DME. Compensating winding reduces flashover at commutator surface. And one more thing is a, yes, compensating winding neutralize armature reaction. So these two notes are very important. Try to remember that. Okay, and you may get one doubt, sir, how this counter EMF is opposing, it is compensating this reactance voltage. So that can be possible by, see that, I mean, if you want to compensate this reactance voltage by using this counter EMF, very important. I already told you interpole winding is connected in series with armature winding. In addition to that, you should be very careful with the interpole polarities here. So I just showed here south and north here. To be frank, one statement is there for deciding the polarity of your interpoles. So what is that statement? Suppose in the direction of generator, let me use laser point, it is very important point here. In the direction of generator, if you want to decide the polarity of this pole, try to see the ahead main pole. What is the ahead main pole here? South pole. It should be south pole. If you want to decide the polarity of this interpole, in the direction of generator, if you want to decide the polarity of this interpole, in the direction of generator, what is the ahead main pole? North pole. It should be north pole. Or, let me take reference as motor. The direction of motor means anti-clockwise in our example. Anti-clockwise, if you want to decide the polarity of this interpole, so polarity of the direction of motor. So if you want to decide the polarity of this interpole, what is the main pole which is behind? Previously, while I was discussing about generator, I took ahead main pole. Now, while I was discussing about motor reference, polarity of interpole is nothing but the direction of motor. Whatever the polarity of main pole which is behind. Here, in the direction of motor, In the direction of anti-clockwise direction, what is the behind main pole? South pole. It should be south pole here. Similarly, in the direction of a motor anti-clockwise direction, so if you want to decide the polarity of this interpole, what is the pole, main pole which is behind here? North pole. It should be north pole. So like that we have to decide. So this point only I wrote here. See guys, in the direction of generator, polarity of interpole is the polarity of ahead main pole. In the direction of motor, polarity of interpole is the polarity of main pole which is behind. If you follow this condition, yes, obviously this counter EMF will compensate this reactance voltage. Okay, let me show you one simple question based on this point so that you'll be having some clarity. A differential compound DC motor. Okay, so yes, let me do one thing. Let me take armature here, brushes. So let me take a main poles here. We already know in DC machine we are using a non-chamfer poles. Okay, so for that reason also I had given. Okay, and this is nothing but the main poles. This axis can be called as D axis, I guess a direct axis. And between these main poles, this is nothing but axis going. So this axis can be called as a quadrature axis. Everybody knows quadrature axis. If you remember clearly in our armature reaction of first video, so I took this pole as what here? Please try to understand. I took this pole as what? North pole and south pole. And here direction of generator, I took it as clockwise direction of generator or direction of TPM is TPM. Direction of rotor in case of generator means direction of TPM. So in the direction of TPM only rotor will rotate. This is a basic thing already you know. So in this example, so I took it as direction of TPM, I took it as a clockwise direction, and direction of motor or direction of electromagnetic torque both are same only. So I took this in the direction of anti-clockwise direction. Already you know that in generator motor action will take place direction of TPM and the TM will be opposite. Okay, that's why I took it here. I took TPM direction clockwise, I took TM direction anti-clockwise. Okay, so here in this question, and one more thing, please try to be careful. So here I should use interpoles here. Interpoles should be placed along which axis? I already told you, along Q axis. Let me show you interpoles along yes, Q axis here, along Q axis, okay, and so let me take interpole winding also. It is connected in series armature. Yes. Yeah. Now let us see. Let us see. Everybody knows that I already told you previous. To note this note. So if you want to decide the polarity of this interpoles, how can you decide that? In the direction of generator. So if you want to decide the polarity of this interpole, what is the ahead main pole? South pole. It should be south pole. And in the direction of generator, in the direction of clockwise direction, in the direction of TPM, if you want to decide the polarity of this interpole, what is the ahead main pole? North pole. It should be north pole here. Okay. Suppose if you want to take in terms of motor also, you can say no problem. In the direction of motor, if you want to decide the polarity of this one, what is the main pole which is behind here? South pole. It should be south pole. And in the direction of motor, I can say in the direction of anti-clockwise direction, if you want to decide the polarity of the center pole, what is the pole which is behind here? North pole. It should be north pole. Okay. Now here my question. So this much everybody knows that already we discussed here. So here my question is, initially it is a differential compound DC motor. So please do one thing. Initially it is a compound, differential compound DC motor. So guys, you know, differential compound motor may be long shunt or maybe short shunt also. Let me take example short shunt. Already you know in a compound machine you'll be having both shunt field winding and series field winding. So let me take shunt field winding here. I took here example short shunt. It doesn't mean you can take, if you want you can take short shunt, long shunt is nothing wrong. Okay. So let me take here short shunt. You know what short shunt? Series field winding connected in series with supply in case of motor. Okay, so guys, initially it is acting as differential compound DC motor. Okay, so if it is acting as a motor means definitely direction of IL will be like this line current. This is about RSC series field winding resistance, RS shunt field winding resistance. Direction of ISC will be like this. Direction of ISH will be like this. Direction of IA will be like this. Now, so guys, you please tell me in case of differential compound DC motor, if you want total flux, if you want total flux, pi equals to what is the relation I can write for net flux for total flux in differential compound machine? It's a pi sh minus pi s. That means, guys, this pi s is corresponding to, okay, this let me use laser pointer. Okay, yes, this pi sh, this pi sh is corresponding to this ish. This minus pi s is corresponding to this isc direction. Is it okay for you? Now what is saying? So if it is a differential compound motor, yes, I took I mean this one differential compound motor. So please let me write here, nothing wrong, I'll write here, it's a differential compound motor. So in differential compound motor, please try to tell me. I told you in direction of motor, if you want to decide the polarity of interpole, so you have to see the polarity of your behind main pole. Yes, in the direction of TM, in the direction of differential compound motor, what is the polarity of main pole which is behind here? South pole. Yes, south pole, north pole, everything is fine. Okay, everything is fine here. But what is asking here, it's differential compound DC motor with the interpoles and with the brushes on the neutral axis is to be driven as generator. That is very important here. So now we just want to use this motor as generator here. You just want to use a motor as generator. So let me use different color here. Yes, you just want to use this machine as the generator. It's a DC generator now. So now my question is, yes. So same, otherwise let me do modification here only, that is better. If it is acting as generator, guys, direction of IA will be what? Upwards. Direction of IS will be like this. Direction of ISC will be like this. Direction of IL will be like this. Now IL becomes what now? Load current. Generator point of IL means what? I guess load current. And one thing you have to remember, I told you in a compound machine, you will be having both shunt flux will be there and a series flux will be there. But shunt flux contributes 80%, series flux contributes only 20%. So which one is more dominated here? Shunt flux is more dominated. I can neglect series flux for some time. Okay. So this is more dominated here. This is more dominated, I guess. This is more dominated. So here my question is, try to understand clearly. If it is acting as generator, guys, please tell me what is the formula, what is the formula I can write for total flux. Okay, pi equal to what I can write? Previously this pi sh is corresponding to this ish. Now it is acting as generator, so this blue color arrow mark. So this IS is, I mean, is there any change in ISH in case of motor and generator now? No. Therefore, previous I wrote here pi sh. Now also I should write pi sh only. So please guys, let me write here pi sh only. And be careful. In the previous case, here I wrote minus pi s. This minus pi is corresponding to, I can say, this arrow mark, this black color arrow mark. Okay, okay. And now it is acting generator means at that time IS direction is upwards now. So obviously, yes, direction of series field winding current is changing. So instead of minus, you should write here what? Plus pi s. That is very important here. Okay. So please let me write here pi equal to pi s plus pi s e. So tell me where you'll be having flux will be added up in a cumulative or a differential in a cumulative. It's a common sense. So obviously I can write here it's a cumulative. Previous is differential compound is a motor. Okay. Now it is acting generator at the time. It is nothing but it's a cumulative. It's a cumulative compound DC generator. Okay. So guys, your answer, if you observe clearly, you can neglect this. You can cancel this option C and option D. Yes or no? Yes, because initially it is a differential compound DC motor. Now it is acting as cumulative compound DC generator. Also common sense that. Now my question is, among option A and B, which one is correct? That is my question. Which one is correct? That is my question. Simple question I am asking. Okay, please try to understand. Try to understand clearly. So for that, how can you decide that? Very simple. So guys, try to understand. Previously, it is acting as the motor. So let me use the black color for that. If it is acting as motor, this TM proportional to, I'm saying when in case of differential compound motor, let me write here itself otherwise. Let me write here only, otherwise you'll be having some confusion. Yes, it is acting as differential compound DC motor. At that time, I'm saying at that time, TM is proportional to pi into IA. I told you which one is more dominant here? Shunt flux. So please try to take here shunt flux only for some time here. Okay. So guys, yes, this pi SH is corresponding to this ISH. Okay. This IA is corresponding to, okay, this direction, the direction of this IA. Means that is the motor at that time. Whenever IA is downwards, ISH is right to left. At that time, I took TM like this. So you know TM, I assumed initially it's anti-clockwise direction. So please take it as anti-clockwise direction. Okay. Now it is acting as cumulative compound. It is generator. Okay. So guys, please try to understand in generator, everybody knows that direction of TPM and TM will be direction of TPM and TM will be opposite. Direction of TPM TM will be opposite. Everybody knows that. You know, I already told you in basic, in a simple diagram of this generator. In a generator, motor action will take place. Because of motor action, electromagnetic will come into picture. Direction of TPM TM will be opposite. So guys, this TM is related to electrical quantity, whereas TPM is related to, I can say, mechanical quantity. So please try to see this TM. Okay. After that, I'll by seeing the direction of TM, I'll decide the direction of your TPM. Okay. So please, when it is acting as a DC generator, so let me use this color here in DC generator. So TM proportional to what? Once again, pi IA. So which one is more dominant here? Pi SH. Tell me, is there any change in ISS when compared to the previous ISS? No. So therefore, there is no change. This one, I took it as a pi is plus value. Here also plus value. But please be careful, guys. Previously, IA is downwards. Now IA is upwards. So obviously, your IA becomes minus IA now. Your IA becomes what I can say minus IA. So previously, this TM is positive. Now this TM becomes negative. I can say here positive. I can say negative. Previously anti-clockwise, now it is what I can say clockwise. So guys, I can write here simple one arrow mark here. So even it is what it initially is active differential compound motor, at that time this is okay. And please tell me what about this arrow mark? I can say electromagnetic torque direction. I can say clockwise direction. This TM is what I can say. So in cumulative compound DC generator, I can say in a cumulative compound DC generator, TM is due to which one? Is due to motor action. Okay. And everybody knows that this generator TPM T will be opposite. Whenever TM is clockwise, what about TPM should be? I can say anti-clockwise. No. So let me take. So this will be. I took it as. So let me show you somewhere. Excuse me. Yeah. So please. Yes, let me show you here. This is nothing but what I can say TPM. TPM, or I can simply direction of cumulative compound DC generator. Let me write here cumulative compound DC generator. Okay. So now initially this is what our reference. It's a differential compound motor. At the time I can say your interpol polarities are south north here, and whenever it is acting as if it is acting as generator, so obviously generator rotates in the direction of I can say anti-clockwise here, anti-clockwise. In the question also he asked the same thing only. See, he just want to driven this motor as generator in the direction of motor. In the direction of motor means what? In the direction of differential compound motor. He just want to run cumulative compound DC generator in the direction of you can say differential compound motor. Yes, previously I took a direction of differential compound motor direction anti-clockwise. Now this is also anti-clockwise direction. Okay. Now please. I mean obviously option E, among option E and option B is your answer. So but my question is, tell me what about interpol polarities? That is very, very important here. So for this question, there is only main hint. So please try to understand, try to solve this question. It's very simple thing only, but try to think clearly. So then you'll get answer clear. Tell me. First of all, check clearly. Initially, this south pole, comma north pole are nothing but polarities of interpoles. So those are related to differential compound. I can say motor. Now, please, this I mean your machine is acting as cumulative compound this generator. You have to cross check clearly whether these polarities are correct or wrong. I told you in the direction of generator. In the direction of generator, if you want to decide the polarity of this interpole, try to see the ahead main pole. What is the ahead main pole here? North pole. So it should be what I can say north pole. And in the direction of generator, in the direction of anti-clockwise direction, if you want to decide the polarity of this one, so in the direction of in the cumulative compound generator, so let me use laser point here. In the direction of cumulative compound this generator, in the direction of anti-clockwise direction, if you want to decide the polarity of this interpole, what is the ahead main pole here? South. It should be what I can say south here. So let me write here south. Okay, so obviously here in place of south, north has to come. In place of north, south has to come. But here my question is, tell me this south is changed to north and north is changed to south automatically, or you have to change manually? That is my question. So here among options, if you see option A, it's a be a cumulative compound generator, but the interpole coil connections have to be reversed, or without reversing interpole winding, without reversing interpole coil connections, this south pole becomes north pole becomes south pole automatically. That is what my question. Simple question I'm asking. Please try to think and try to just decide yourself. Okay. So tell me. So is south is becoming north and north is becoming south automatically, or you are reversing interpole winding connections? So option A is correct. Option B is correct. That's what my question. So please try to think and tell me clearly. Okay. So my question, I'm asking very simple question. So this south is changed to north. South has to change to north. North has to change to south. But my question is this happening automatically, or is this happening by changing interpole winding connections? That's what my question. So guys, don't confuse. Some people are going for option. It's a B cumulative compound generator, but interpole coil connections have to be reversed like that they are saying. Sir, if you want to make south pole to north pole to south pole, sir, definitely I need to reverse the interpole connections, sir. Like that they are saying. That is not correct. Why? I told you guys already. Here, interpoles winding is connected in series armature winding. Okay, that means that is the main hint for this for this question. So initially is acting differential compound motor at that time IA direction will be downwards. If it is acting as cumulative compound, this generator direction of IA is what I guess upwards. That means automatically direction of IA is reversed. Whenever IA is reversed, direction of interpole winding current also reversed, because interpole winding is current in series armature winding only, no? So whenever armature winding current is reversed, interpole winding current also reversed automatically. So obviously the south is changed to north, north is changed to south automatically. There is no need to do manually. So your option A is not correct here. Option A is not correct here. If you see option B, it's a cumulative compound generator without reversing the interpole coil connections. What is the reason for that? Since interpole winding is connected in series with what? Is connected in series with the armature winding. Okay. Whenever armature current is reversed here, so automatically interpole winding current also reversed. So your poles will change automatically. South is changed to north, north is changed to south automatically. So obviously option B is correct. Option A is not correct. Okay, be careful. Okay. So this is a question asked in GATE 1995 for 1 mark. And let us see one more question here. It's a very simple question only. Please try to respond. In a DC machine, which of the following statements is true? Let me see option A. Compensating winding is used for neutralizing armature reaction. Everybody knows that this is correct statement only. But while interpole winding is used for producing residual flux. Is it correct statement? No. Interpole winding is used for reducing CME, reducing spark with brushes, improve commutation. So option A is not correct. Let me go for option B. Compensating winding is used for neutralizing armature reaction, while interpole winding is used for improving commutation. Yes, correct. Option B is correct. If you want, you can check option C and option D. That will be wrong. See, compensating winding, option C I'm saying. compensating winding is used for improving computation. Is it correct? No. For improving computation, I'm using interpoles, not compensating winding. And option D also, compensating winding is used for improving computation. No. So for improving computation, I'm using interpoles, not compensating winding. So option B is correct. Okay, guys. So this is about interpoles or compoles. Okay, and okay, and some questions based on interpoles and compoles. Okay. So guys, in the next video, I'll be discussing, okay, characteristics of DC, I mean DC generator, all those things we'll see. So that's it for this session. We'll see in the next video. We'll be discussing characteristics of a DC generator. Okay, thank you.